Good morning everyone. Today we are going to discuss about electric motor and generator. Motors and generators are essential for modern technology and magnetic induction is the phenomenon that make them work. Let's study first electric motors. The electric motor first appeared in the 1740s through the work of Scottish Benedictine monk and scientist Andrew Gordon. An electric motor is a machine that converts electrical energy into mechanical energy. Electric motors can be found in a wide range of applications from household appliances like washing machine, blender, and refrigerator. Here are some basic parts of electric motors. An electric motor will have an armature with current running through it and either another electromagnet or permanent magnet. The standard armature is made up of a solenoid. Keep in mind that the more solenoid coils and more current running through them, the stronger the electromagnet. The stronger the interacting magnetic fields and more powerful the motor. In general, electric motor have three main parts: a stator, a rotor, and a commutator. These three parts use the attractive and repulsive forces of electromagnetism, causing the motor to spin continually as long as it receives a steady flow of electric current. Every electric motor has two essential parts. One is stationary and one that rotates. A stator is most often a permanent magnet or row of magnets lining the edge of the motor casing. Inserted into the stator is the rotor. When electric current flows to the coil, the resulting magnetic field pushes against the field created by the stator and makes the axle spin, usually consisting the copper wire wound into a coil around an axle. On the other hand, the commutator, which sits at one end of coil, is a metal ring divided into two halves. It ensures that the ends of coils do not move in opposite directions and ensures that the axle spins in one direction. In addition, at one end of the motor are the brushes and terminals. The brushes sends electrical current to the commutator and are typically made of graphite. Remember that motors can be brushes too. On the other hand, the terminals are the locations where the battery attached to the motor and sends the current to spin the rotor. There are two classifications of electric motor. Most motors are powered using different current, which is produced by cells and batteries. Motors powered by main electricity use alternating current. These motors use electromagnets rather than permanent magnets. How does an electric motor work? A battery is used to magnetize the coils. Creates a magnetic field traveling north to south outside the coil. North end of the coil is attracted to the south end of the magnet. Vice versa for the south end of the coil. This attraction causes the axle to make half a rotation.
Okay, so good morning everyone. My name is Jaycer. Miss Nicole presented earlier about the electric motor. And I'm here to present about electromagnetic generator. Okay, so electromagnetic generator discovered by a physicist Michael Faraday in 1831. Electromagnetic generator convert mechanical energy to electrical energy. It operates based on the principle of electromagnetic induction. It means electric generators work on the principle of electromagnetic induction, where a relative motion between a magnetic field and a conductor induces an electromotive force or voltage across the conductor. This voltage can be used as electrical power. This is an example of electromagnetic generator. The thing that rotates is a coil placed in the magnetic field. The magnetic field is from north to south pole. And when the coil rotates, it creates electricity. And there are two types of generator. If the direction of the current changes after every half rotation, this type of generator is called AC or alternative current. Alternating current generators, commonly known as alternators, are widely used in power generation systems. They use the mechanical energy from turbines or engines to generate alternating current, which can be modified and distributed for various applications. However, when the direction of the current doesn't change, these generators are called DC or direct current. DC generators are used in a specific application where a constant voltage is required. They find applications in battery charging systems and certain industrial processes. So that's all I have information about electromagnetic generator. I hope you learned something new and goodbye.